Taste Filip!
Yeah. So this is advanced traffic obfuscation made easy by me. So who am I? I'm a Swedish student and I only read one course, so I have a lot of free time to do infosec stuff and hack on various projects. On my free time I do some pentests. I'm an open source programmer. I'm involved in various open source projects, including DuckDuckGo. So if you're looking for a better search engine, I would recommend that you check that out. Lately I've been doing a lot of research and not so much pen testing. I've been working on my own antivirus. I've been working on kind of other people's antivirus. I report a lot of viruses. And yeah, that's who I am. So what is obfuscation? Well, obfuscation basically means take one thing, make it look like another. Obfuscation systems are basically deployed all over around the world to circumvent censorship. One really popular obfuscation system is Tor. I'm sure everyone heard about Tor. So obfuscation systems are basically categorized into 4 different categories. Some people say it's 2 different categories, but depends on what white paper you read. You get randomization, where you take the original data, you encrypt it with a stream cipher, you kind of remove all fingerprints of the original data. And systems that work this way is OBFS 2 to 4, and you get scramble suits. Then you got mimic, which is when you mimic a certain characteristic of a certain protocol. So if like SSH is blocked in one country, you just make it look like FTP. One system that works like this is Ligotaurus, where you take recorded HTTP data and then you kind of inject the data you send to it with 2 different stenography techniques. You also get Skype morph, which is, well, it mimics the Skype protocol, makes it look like Skype. And then you get tunneling, which is another category, which is tunneling one protocol inside another. You get freeway, which tunnels TCP and ZIP, and ZIP is actually also TCP. ZIP is a voice over IP protocol that is very popular. Then you get sensor spoofer, which uses 2 channels, one upstream channel and one downstream channel. But this is only a white paper. What I have seen is it hasn't been a real system. I tried to email everyone who was involved in it and developed, but no one answered. And then you get programmable systems, which are basically built on the thought that all these other systems are kind of single use. They're kind of hard to reprogram to do what you want. So you get Marionette, which was released around a year ago, which is kind of a beta system also of a programmable obfuscation system, written by a dude named Kevin P. Dyer, he's amazing. That's what he does. He also wrote FDE proxy. So I took Marionette, I looked at it, I reprogrammed it to kind of make it do what I wanted. So this is basically how it works. The user set up 2 computers, a client and a server. The user then connects to the client with Marionette comes with a SOX 4A proxy, but I added a SOX 5 proxy to it, so you can choose, because more programs support SOX 5. And then you can send your data with a SOX 5 proxy to the client, you then encrypt it, and then you add spoof data on top of it to make it look like something else. And then you send it to the server. So obfuscation systems are basically built to avoid DPI system, Deep Packet Inspection System, so like the Great Firewall of China. But they're not really that great for manual inspection. So this is like a GET request generated by an obfuscation program. It bypasses pretty much all DPIs, but if you were a man-in-the-middle attacker and you sell HTTP requests looking like this, at least I would be real suspected, and I would look more into that. So they kind of fail at manual inspection, but are great for DPIs. So spoof data, what data can we spoof? I looked at HTTP, and my goal is not only to generate HTTP requests that look very legit, I actually want to be able to click on the link and actually get somewhere. So I wrote this simple syntax. I found that there are proxies with the web UI So I wrote this simple syntax. So the GET request looks like /web proxy URL, and here we generate our URL. So one of these links is spoof, and one of these link is legit. As you can see, it's very hard to determine who is legit and who is not. Anyone want to guess who's the legit?
The lower one, I think, is the legit one.
What did you say?
No, the one.
The
I think the lower one is the legit one. It has base 64 encoded data, and it has a lot of zeros and stuff.
yeah, it's actually true. So it's kind of really easy, relatively easy, to make it look like it's legit. So censorship. What people basically think about when they heard DPIs is deep package inspection systems. A lot of people doesn't really know about deep package injection systems, which are deep package inspection systems. Kind of looks at the data, and if the data is bad, it blocks it and it's recorded. But then you get those more advanced systems where deep package injection data is. So if it sees a package going to WikiLeaks, it could then inject some bad stuff into that package and kind of infect you. Systems that use this is Qfire, which actually is really hard to find research on. It uses satellites and everything. I tried doing research on Qfire. It's actually developed by the NSA, and I only found one paper. I even searched on WikiLeaks for Qfire, and nothing turns out. So this is a real funny picture of the sign. If you have nothing to hide, you have nothing to fear, which is basically what a lot of people think when that doesn't encrypt the data. What is really funny is not the sign, it's the location of the sign. This is the Utah data center built in 2013, which is a private data center built by the NSA for the NSA, and with this sign outside, out on the front. So it may be spying on you. So internet traffic. In 2015, approximately 76 exabytes were traveled over the internet. In USA, it was 2 exabytes, and to kind of record all this data, to record 2 exabytes of data, it would cost $200 million, and it would be a lot of hard drive space. So my guess is they're probably targeting specific protocols like zip, which all zip is only estimated to be 224 petabytes and cost 30 million. And then a lot of people have been publishing research about NSA programs such as PRISM, where they don't record data that looks like it's coming from Google, looks like it's coming from Facebook. And going to Facebook, they just go to Google and say, hey, can we have that data for this user at this exact time? So if we then can generate data that looks like it's going to Google, we don't get caught in these DPI systems. So we hide it in plain sight, basically. So I was actually caught in a deep packaging inspection filter, and it was not by a government, it was by a small ISP called DG Access, which I do some pen tests on my free time, and I basically automate the whole scanning process, and then to log files, and then I kind of look at those log files and, oh, there's a server I want to target. So I was doing that for a specific client, and I started scanning, and then my SQL server pops up. I think, oh, that's great. I just run my SQL fuzzer on it, and maybe I will get some access or something. And I go to bed, forgot that I was running the SQL fuzzer in the background. I then bring my laptop to school, and a week later I was called into the IT guy's office. So I tried to explain to him that I actually was a pen tester, and the whole situation got very awkward. Anyhow, the next day I went there again. He also took my computer and went through with this and found Sue's version from 2007, and I was like, yeah, I'm a malware researcher, I have malware samples from 2007, but if you know anything about IT security, you can't infect someone with the public SUS virus is from 2007. So anyhow, in Sweden we got this amazing law called förtal, which is basically you can't accuse someone of a crime. So I said, if you want to take this any further, I'm gonna call my lawyer and I'm gonna start a legal case against you. So I turned out okay. So is this secure? Well, it doesn't log any client IP. I also combined it with a Tor relay. So if someone would end up in a legal case using this, my obfuscation system, it's kind of hard to prove which data is coming from the Tor relay and which data is coming from the client. I implemented as strong as I can encryption, and I made it kind of hard to fingerprint and hard to block, which you can basically, with this system you can basically generate HTTP. It's very easy to generate different packages, and it's kind of hard to protect against deep package injection systems such as Qfire, which use satellites. But I kind of sign all data with PGP, and then verify it, and if it doesn't go through, it breaks. So I tried implementing that. So the crypto, first I was running PGP with script, and well, I thought it was a good approach to this, but script is really slow, and I was having a lot of problems. So I talked to a developer of an application called SecureTech, and that's what he used. He said, I use off-the-record encryption. I consider that to be really secure. So I looked at off-the-record encryption, which is basically 1024 DSA key. They kind of exchange, and the SHA-256 HMAC. They kind of exchange that against PGP. So pentest. Maybe someone here is a pentester, and can I use an obfuscation system in a pentest? Well, some people say no. I say hell yeah. So you can generate links that look like someone is visiting your website and so on, and make all the links that you're generating redirect into one site where you have a beef hook or an evil JavaScript or a browser exploit of some kind. I have a demo of this. Okay. So sorry for this, I thought it was gonna work. So, can anyone see here? So,
Can't you go full screen? Or
yeah, I tried, but
disappear
nope. Doesn't want to work. Okay, let's play it like this. So, here I got LayerProx, which is this obfuscation system running, and I'm generating requests that will point out to my site where I have a beef hook. So, so here's the HTTP request being generated. Oh yeah, so if we look at one of these HTTP requests, it's kind of hard to see due to the resolution. It's being generated. So if I curl one of these HTTP requests, I will actually.
Can you pause and maybe zoom in for
Yeah,
a
yeah.
moment that we can actually see the what we maybe on the
If you make
terminal on the right, because everything is in there. That is important, isn't it?
Yeah.
I know.
And a Mac Pro here.
Yeah.
If you just make the VS window bigger than like it used to be,
yeah.
then you can show parts of it.
There's the screen zoom with control and holding down control.
Yeah, but it will not
doing
make the window any clearer. So I think you need to expand the window. Yeah,
So
like
yes,
that.
now.
Yeah.
Because we just type command plus.
There we go. Nice.
So flipchan.se is my website. So I basically created this kind of thing where everything slash news slash something gets redirected to one site. So I then generate a GET request that looks like it's going here, and if the maninthemiddle attacker actually were to copy that link, press that link, he will then think it's a 4.4 page, but what he doesn't will see is the beef hook and the evil.eas, so we can actually hack the people who are running maninthemiddle attacks against us. So everyone here can be a shadow broker. Cool.
Can you take that again, what you actually did? You generated...
I generated a URL, HTTP request that looked like it was going to a website I host. So I have basically a syntax on my website, so everything /news will kind of redirect to one site where I have an beef hook and then JavaScript payload in it. So if anyone were to like go on flipchan.ac /news /something, it will actually end up on that page that with the beef hook in it. Is that an answer?
So if someone was intercepting your traffic and then went to that same URL just to check it out, you were capturing it?
Yeah, so believe this scenario that you have the man in the middle. You have, let's say I have my computer here, and the server that I'm connecting to is in Canada or whatever. The kind of data that looks like it's coming from my computer and going to the server is this HTTP request that we generated. So it looks like we're visiting a proxy with a web user interface. Is that okay answer?
Sorry to ask that, like mean, but what is it good for again? I also don't really get it now.
For the surveillance state.
Okay.
If they manually copy and paste it, they will actually go to the beef hook and hack the hackers.
Okay.
So that's the fun
Okay.
part.
Yeah. Very good.
So it's for the surveillance state. It's awesome.
Thank you. So there's been a lot of report about screening column, which is a couple of assholes in Sweden sending out requests to people who torrent DMCA guys. So I kind of played around with BitTorrent a little bit and got the TCP to work and kind of combine. Like I said earlier, I had run a Tor relay also on my server. So it would be kind of funny if they actually try to trace someone and they see the Tor relay. So a YouTube link is kind of harder to generate because it's any link lower than 23 character is for some case doesn't work. Me and Kevin P. Dyer, we spend a lot of hours trying to figure out this and basically come up with a solution why it's hard to generate. It's the Python regex, which kind of sucks, which is the DSL, which is a domain-specific language used to kind of generate. So if you want to generate like a GET request. This is what it looks like. So I kind of wrote my own that is much easier to implement. If you just want to generate numbers, you basically type in the URL you want to generate, then the number, then the length of the numbers you want to generate, and then that is, you define that as HTTP. The same work as characters if you want to generate that. So DNS, there's been a lot of talk about people being de-anonymized thanks to DNS. Well, basically, don't use Google, don't use 888. Use the DNSSEC over Google. That is what I've been told is very good. There's a lot of good public DNS resolvers, such as the Chase Computer Cloud got one. Censorship does. DK.
You mean over Tor, right? You said over Google, but you mean over Tor?
Yeah, basically DNSSEC. I kind of proxy all DNSSEC.
Yeah,
over
right.
Tor.
But you said DNSSEC over Google. I think you meant over.
Oh, yeah.
Yeah.
And DNS watch. So why stop with HTTP? I only generated HTTP. So we can basically generate whatever protocol we like, SSH, FTP, SIP, whatever. So I actually have a demo of this, generating FTP. Hope that this works. Is this in full screen? No.
Can I ask another question to you?
Yeah, of course.
To use your LayerProx, do you have to have both the SOX proxy and a web server that is redirecting to wherever you're going, or I'm not sure I've understood it.
Yeah, you could. I'm actually gonna. I'm working on getting like public service out there. I've been talking to an ISP that is very privacy concerned, so it will eventually get public, and then you can just run it from a client from your computer. But if you want to set up it today, you need a server, and then you need, well, your client machine.
Okay, but a server to run the proxy on, or
Yeah, as a host to send the pressure, like a VPN.
Also on that note, if that became, if there were lots of public servers like that, wouldn't places like China basically blacklist those servers in the first place, and would prevent that approach? I mean, you would still be connecting to that proxy, and if those are publicly known, then it would be an issue, or not?
Yeah. That's obviously a problem, which Tor basically have the same problem. Okay, I think this worked. So here I built a scenario where you get one man-in-the-middle attacker that kind of built a DPI system that targets FTP. So I generate a lot of FTP requests. Here are my generated FTP requests. So if the man-in-the-middle attacker actually were to look at one of my requests, I sent him a nice little message in it. Nice try / OWASP hacker. Just to kind of fuck with him. So you can do a lot of cool things. So yeah, there's a new domain-specific language out. It hasn't been completely bug-proof, but it works pretty good. And so what's next? I'm building an open BSD port on it, and as I said earlier, I'm currently talking to an ISP who maybe who is going to host some public service so anyone in the world can use this. And I'm gonna add it to the Debian package list. So, thanks for listening. I didn't expect the technical errors, but I would like to thank Kevin P. Dyer, which has helped me a lot with this project. I would like to thank 2600, who has been supporting me. I would like to thank Klondike for helping me out with some encryption. I would like to give a shout out to everyone on Freenode in the programming channel for being awesome. I would also like to thank OVAF for creating this awesome event. And it's open source, so you can hack it, break it, rebuild it, do whatever you want. If you want to get in touch with me, you can email me at flipchan@riseUp.net. And I'm sorry for the technical problems. Any questions? Okay.